This is going to be topic 11, additional product solution. So for the following functions, we are asked to find the vertex, the y-intercept, and the x-intercept, or intercepts, if any, and sketch the parabola. So, the first problem is f of x is equal to x squared minus 4x plus 4. Okay, notice that this is 1 times x squared minus 4x plus 4, and that the a is 1, the b is negative 4, and the c is 4. All right? So we already know, because a is positive, smiling, that it's going to be opening up. And so our vertex will have to be a minimum. So let's find what that is. Our x-coordinate of our vertex is negative b over 2a. So it's negative times a negative 4 divided by 2 times 1. So a negative times a negative is going to be a positive. So we got 4 over 2, which is just 2. So what's the y-coordinate of this vertex? It's going to be the function evaluated at 2. That's the height, right? The function always gives us the height. So this is 2 squared minus 4 times 2 plus 4. All right, so that is 4 minus 8 plus 4. And this one, it turns out, is going to have a y coordinate for the vertex of 0. Okay, so that's part A. So part B was the y-intercept. So the y-intercept, remember, is really easy. It's when x equals 0. So f of 0 is equal to 4. Okay, so we can start putting together our little xy table. We know we need some points on either side of the vertex. So let's see, our vertex is at 2. And the height was 0 there. And then we have this point x equals 0. I'm just going to put it here. This might be wrong. We'll see where the x-intercepts turn out to be. But I'm going to put that at 4 because 0 comes before 2. That's why I'm putting it higher up in the table. Okay, so now let's figure out those x-intercepts. The x-intercept is where y equals 0. All right, which is the same thing as when the function is equal to 0. So we want to find out where, what x makes the function 0. Okay, so in order to set that up, we're going to set up our function, which is x squared minus 4x plus 4 equal to 0. Okay, and now we can ask, well, we can jump right into the quadratic formula, or we can try factoring it. Whenever I see numbers that are small and kind of easy to work with like this, I usually give factoring a chance. So let's see. We need to find 2 numbers that multiply to positive 4 and add up to negative 2. Excuse me, that add up to negative 4. So how about negative 2 and negative 2? And when we do that, we are going to confirm our vertex, actually, because this is going to tell us that this is equal to 0 when x is equal to 2, right? Setting up x minus 2 equals to 0 and solving that. gives us x equals 2, and that is going to happen twice. So whenever we have one x-intercept, it becomes the vertex, and it is a double x-intercept in a sense. Okay, so we might want to just go ahead and get 1 point bigger than 2 so we can plot this on the other side. Like, we know this is symmetric, so maybe if we picked a number like 3, we would get, so for f of 3, we get 9. So just to be clear what I'm doing, I'm plugging into the function. I'm going to plug into here. So I get 3 squared minus 4 times 3 plus 4. Okay, and that equals 9 minus 12 plus 4. And that's going to give me 9 plus 4 is 13 minus 12 is 1. So at 3, I'm going to have a 1. All right, that's sufficient. I now have that my x-intercepts and my vertex are the same, and it's just the point 2, 0. So let's go ahead and graph this. So if we go over to 2, 0. We also have a y-intercept at 0, 4. Sorry, switching colors on you a little bit. And we have another point at 3, 1. So that's 3, 1 right there. Okay, so let's go ahead and graph this. So again, it doesn't have to be absolutely perfect. We could have filled in another point here. I suspect if we put the point 1 in, we can check that. If we put the point 1 in for x, we would have gotten 1 minus 4 plus 4, and that would have equaled 1. So we actually need to have that point there. And I knew that because of the axis of symmetry for the parabola. All right, so that's 1. So let's go on to number 2. Number 2, the function is minus 2x squared plus 6x minus 3. All right, so I already know that this is a is equal to negative 2, b is equal to 6, and c equals negative 3. I know that a, which is negative 2, is negative. A is negative, right? So it's frowning, okay, which opens down. So frown down, okay? And that means that our point of our vertex is going to be a maximum. So let's go ahead and find out what that vertex is. So the vertex, the x-coordinate of the vertex is given by negative b, so negative 6 over 2a. All right, we have two negatives, a negative in the numerator and a negative in the denominator. Those are going to cancel out, and we're going to have 6 over 4. And 2 is a factor of both of those, so we're going to go ahead and simplify that down a little bit, and we're going to say that's 3 times 2 and 2 times 2, and the 2's cancel out, and we get 3 halves. Okay, so what's the y-coordinate of this vertex? Well, it's the function evaluated. I'm going to go ahead and put it here. It's the function evaluated at 3 halves. Okay. So this is going to be minus 2 times 3 halves squared plus 6 times 3 halves minus 3. So this looks easy enough that maybe we can go ahead and do it out. Minus 2 times 9/4, right? That square has to go on both the numerator and the denominator, so it's 9/4. Okay, this 2 can cancel out with a 2 in the 6, leaving us a 3. So 3 times 3 is 9 minus 3. Okay, and then we have the 2 here canceled out with one of the 2's that's in the 4, leaving a 2 behind. So now we have equals negative 9/2 plus 6. Okay, which we can also write as negative 9/2 plus 12/2, leaving 3/2. All right, so we have an x and a y intercept, so xv, yv is equal to 3/2, 3/2. And maybe we can start putting together another xy table for our parabola. We know that the vertex is going to have an axis of symmetry, so let's go ahead and write this. We can write this as 1.5, 1.5 if you'd like, but we're going to find points on either side of that. All right, so B says, what's the y-intercept? Remember, this is the one that's easy. This is when x equals 0. So f of 0 is just negative 3, right? If I look at this function, everything with an x goes away. It just becomes 0, and I'm left just with a minus 3. Okay, so let's go ahead and put that in our table. So we have 0, minus 3. Okay, now let's go ahead and find the x-intercepts, or intercepts. And we know that we can get this by setting our function equal to 0. So minus 2x squared plus 6x minus 3 is equal to 0. So again, I'm going to take that function, and I want to know where its height is equal to 0, because that's the x-intercept, right? So going ahead and solving with a quadratic formula this time, I want to try to make sure I can still see that function. So we have that x is equal to negative b plus or minus the square root of 36, because that's b squared, minus 4 times minus a, which is minus 2, times c, which is minus 3. And I'm going to extend that square root over that whole thing, and I'm going to put the entire numerator all over 2 times negative 2. Okay, so doing that, in the numerator I have minus 6 plus or minus 36 is going to be underneath the square root. But let's see, here I'm going to have a 4, a negative times a negative times a negative is 3 negatives makes a negative. And I'm going to have basically 4 times 2 is 8, times 3 is 24. So I'm going to extend that square root over that whole thing. And in the denominator, I'm going to have a negative 4. All right. So we can factor out a negative and a positive, a negative from both the numerator and denominator. And we can have 6 minus plus 36 minus 24 is going to be 8, right? No, 12. Yes, 12. All underneath the square root sign, and then we get a 4 here. All right, now remember, you can't make up weird math and suddenly, I don't know, do something weird with this 12, but we can see if there's factors that are perfect squares that we could pull out, and there is. So we have 6 minus plus, and the square root of 12 can be written as 4 times 3, all over 4. And so now that this is a perfect square, I can take the square root of it, and I can pull it out by taking the square root, and I can get that to be 6 minus or plus 2 square roots of 3 all over 4. All right, so since we're trying to build numbers into our, well, we could do one more step because it's probably good for your practice. Pull out a 2 from the numerator. There's a 2 in the 6, and there's a 2 in the second term. We'll pull out a 2, leaving a 3. minus or plus the square root of 3. In the denominator, we have a 2 times 2, right? That's 4. So we're going to cancel out these hidden form of 1. And we're just going to get that we have 3 minus plus the square root of 3 all over 2. So let's go ahead and fill that out in our table. So that means that we have x equals 3 minus the square root of 3 over 2. And if I put that in my calculator, I get that this is 3 minus, then I want to do the square root of 3. And then I want to take that and I want to divide it by 2. So I get that this is equal to 0.6. So to be able to draw a little clearer with this pen, I'm going to go and say that the y is a 0, right? Because it's an x-intercept. Right, so that's the height. And it's going to be a 0.6. So actually I want to put it, I'm going to go ahead and put it up here. I'm going to move that and write this as a 0, -3. And then this is 0.6. And it came out to 0.6. So and the height is 0. All right, so now let's get the other one. So it's x is equal to 3 plus the square root of 3 over 2. All right, so let's see what that comes out to be. 3 plus the square root of 3, and divide that by 2. And I get 2.4 to 1 decimal. Okay, and for a little sketch, 1 decimal is plenty. So we're going to get that this is 2.4. Okay, and with that, that is sufficient for us to do our little sketch of what we need to do. So let's go ahead and come down here. We know we expect it to open down. And it looks like our x-intercepts are all on the positive x-axis. So if I count by 1s, 2, 3, and on the y-axis, I'm going to also count by 1s, 2. Okay, so the first point I always like to put is the vertex, the 1.5, 1.5. So that goes right in between 1 and 2 on both x and y axis. All right, now we can put in, I realize now that we need our y-axis to come down to -3. Now we're going to put in our 0, -3 y-intercept. And then we're going to put in at 0.6, we're going to have an x-intercept. So it's just a little bigger than half, 0.5. And then at 2.4, we're going to be doing our other x-intercept. So this is a very narrow parabola. It's going to go through these points with an opening down. Okay, so we had a value of a on this one of -2. So we've confirmed that we are able to see that because we're opening down. Okay, next problem is going to be problem 3. Okay. In this one, we have f of x equals 16 minus x squared. Now notice, this is not written in the way we normally would see a quadratic, which we always put in descending order of the exponents. So you have to kind of realize it's not necessarily trying to be tricky, it's just trying to get you to dig a little deeper and realize that. So let's put this in the correct order of a standard polynomial. So we would write this as -x squared plus 16, right? I'm just putting these in the opposite order, you can order anything A plus B equals B plus C, right? We can put the order however we want. All right, now it's really clear, though, when we do this, that we have an A that's -1. All right, we have this plus 0x term that's missing. So that means we have a B that's 0. And we have a C that's 16. Excuse me. All right, so the first thing we want to do is just think about what this looks like. So it's opening down, right? So this -1 tells me that it's going to be opening down, negative, frown, down. Okay, so next, let's find that vertex point. The vertex is at -b, so -0 over 2 times -1. I don't have to do anything at this point. I just know it's 0. All right, so if the x-coordinate is 0, we're pretty much going to be getting the y-intercept and the vertex for the same amount of work. So what's the y-coordinate? It's where the function is evaluated at the vertex, the x-coordinate of the vertex, which for us is 0, which is going to be, if you want to use this first one, you can. 16 minus 0 squared is just 16. Okay? So now we know that that point on our vertex is going to be at a height of 16 and an x-coordinate of 0. Alrighty. Next thing, since we already got our y-coordinate, so this is, we can do a little xy table. And we'll start out with putting this vertex, and it's at 0, 16. And it's also the y-intercept. Okay, so we took care of A and B in one shot. All right, so let's go ahead and go to C. And C is going to be finding where the x-intercepts are. And for the x-intercepts, remember, we're going to set y equal to 0. That's the height. Or in other words, we're going to solve where f of x is equal to 0. So it's just all saying the same thing. But that means where is 16 minus x squared equal to 0? Okay. Well, if you view it this way, you can view it this as an a squared minus a b squared. Right? And if you think of that, if you remember, that's a plus b times a minus b. That's one of the forms that we've memorized for factoring easily. So that means we can think of this as 4 squared minus x squared. And work with this as 4 minus x times 4 plus x equals 0. So in that case, we can set 4 minus x equal to 0 or 4 plus x equal to 0. Adding x to both sides, we get that 4 equals x. Or subtracting 4 from both sides on this one, we can say that x is equal to -4. All right, so let's put these values in our table. So I'm going to put these values in. These are the x values, so we have a -4 and a 4. And this was the solution for when y equals 0, right? That's what an x-intercept is. So in both of these cases, y is 0. So now we can do a little sketch of this. So let's say for this one, we're going to count by 5s. So we got 5, 10, 15, 20. That's 20, 15, 5. All right, and we're going to go and we're going to put our y-intercept at 0, 16. So 0, 16, we get a y-intercept. by ones. So this 2, I don't know why I'm making this so complicated. Okay, I want to count by ones. So that's minus 1, minus 2, minus 3, minus 4 here. Okay. All right, now let's go ahead and put in those y-intercepts at -4. Sorry, x-intercepts at -4, 0, and 4, 0. And then we can draw our line through this parabola. And that's, I think, the end of our question.